We're going to pick up where we left off last time. And now we're going to talk about how do you find the arc length of a parametric curve between 2 points. And we actually have looked at this before. What's arc length? Small s, it's the integral of ds, except x and y are in terms of t, so we're going to have to write it as ds dt dt, but the s dt is dx dt squared plus dy dt squared dt. So that's the formula that we're going to use. Okay, let's look at a particular example. Let's find the arc length of this curve from 0, 3 to 4, 7. Well, the first thing I need to do is figure out what values of t correspond to these points. Well, for the point 0, 3, x has to be 0, but what's x? X is 2t, so I set 2t equal to 0, and y, which is t squared add 3, equal to 3. Both these equations have to hold. I picked the easiest one. 2t is 0, tells me what? T is equal to 0. I plug it in here to make sure it works, and it does. So for this point, t is 0. For the point 4, 7, I have 2t equal to 4. 7 is equal to t squared add 3. Again, I picked the easiest one to solve. This says t is 2. And I plug it in here, and sure enough, it satisfies that. So t equals 2 corresponds to 4, 7. Okay, finally, what's the arc length? And the arc length is the integral from 0 to 2, those are the values of t we found, of the square root of dx dt squared plus dy dt squared dt. And that turns out to be the integral from 0 to 2 of the square root of 4 plus 4t squared dt. And there you have it, what's set up, which is all I asked for here. Okay, if I were to have to do that integral, I would be doing it by a trig substitution, but we're not going to do that today. All right, so let's look at another example, example 6. Find all points that correspond to now not horizontal tangents, but vertical tangents. And here's the curve I want to look at. X is t cubed minus 12t add 5. Y is 5 to the t, or 5 times t, plus e to the t. And again, anytime I do parametric equations, I need to tell you where t runs. T can be any element of the reals. All right, so the key is, what is a vertical tangent? A vertical tangent has the tangent line straight up and down, right? Vertical. Okay, what does that correspond to? And the point is, remember, horizontal tangents had dy dt 0 and dx dt not 0. Vertical tangents correspond to dx dt is 0 and dy dt is not 0. All right, why is that true? Because, of course, dy dx is dy dt divided by dx dt. And for a vertical tangent, it should be undefined, which means the denominator should be 0. And the numerator should not be 0. Otherwise, I might be able to compute a limit there. All right, so what's the point? I just take dx dt. And dx dt turns out to be what? 3t squared minus 12. Take that derivative. And dy dt, take that derivative. And I just get 5 times e to the t, which I notice is strictly greater than 0, so I don't have to worry about this thing. All right, so if I solve this, t is equal to what? Plus or minus 2. Both those points correspond to dx dt 0 and dy dt not 0. So I have two vertical tangents, one corresponding when t is 2, and the other corresponding when t is minus 2. All right, now if I want to find the points where those vertical tangents occur, I take these values plus or minus 2, I plug them into x and y. So when t is 2, I plug it in and I get, remember, plug it into x, not x prime, and what I get is 8 minus 24, add 5. I'm plugging it in right here, and I plug in 2 here, and I get 10 plus e squared. I think if I've done my arithmetic right, it's going to be, what? 13 subtract 24 is minus 11. So I get minus 11 there. I get 10 plus e squared there. That's my point where I have a vertical tangent. The other vertical tangent occurs when t is minus 2. All right, so I just take this and I plug in minus 2. And I claim I get, what, 21 comma minus 10 plus e to the minus 2. And there we have it. All right, so that's how you find vertical tangents. Now let's look at example 7. These are all similar to problems in the homework. Suppose I want to find the equation of the tangent line to this curve at a particular point, 5, 7. All right, so what do I need to compute the tangent line? And the answer is, to compute any line, I need a slope and a point. Well, I already have a point, 5, 7. So I'm just interested in the slope. How do I find the slope? Well, remember, the slope is dy dx. And dy dx is dy dt over dx dt. Okay, but once I get that, I'm going to have to plug in a value of t. So I need to find what t corresponds to the point 5, 7, just like I did previously. I take x, I set it equal to 5. What's x? T cubed, add 4t. I take y, and I set it equal to 7. What's y? T squared, add 6. Now, the point is, whatever t value I get has got to work in both equations. So I pick the equation that's easiest to solve, and I claim it's probably going to be this one. So I take 7, set it equal to t squared, add 6. T squared is 1, t is plus or minus 1. All right, so I get two possibilities, but the problem is, to work, it also has to work in both equations. Well, I already know it works in this one, so I plug in both 1 and minus 1 here. Now when I plug in 1, I get 5. That works. But when I plug in minus 1 into this equation, I get minus 5, and the point is that doesn't work. So there's only one place where it works, and that's when t is 1. All right, so when t is 1, I'm at the point 5, 7. So how do I find the slope? I take dy dx, which is dy dt divided by dx dt, and I plug in t equals 1. Well, dy dt, remember y is t squared, add 6. dy dt is 2t. Remember x is t cubed, add 4t. dx dt is 3t squared, add 4. When I plug in 1, what do I get? 2 over 7. So at 5, 7, I have a slope of 2/7. Finally, if I want the equation of the tangent line, okay, It's the line that goes through 5, 7 with slope 2/7. One form of lines there. Y minus 7 is 2/7 x minus 5. And I've answered my question. Okay, so that should put you in good stead. Hope everyone's doing fine. Bye.